Okay, so here's the big video tutorial, the one I think most of us will need. So it's complex circuits. So here's some rules. First, combine any series. So if there are any resistors that are in series, go ahead and combine them just by adding them together. Then resolve parallel systems. So that's what I mean by that, is anywhere that there are parallel resistors, use your equivalent resistance formula for that to boil that down into a resistance, and we'll call that the resistance of that system. Then 3, combine systems in series. So now you should have all of these systems have a resistance, and they should all be one after the other, thus in series, so you can just combine them by adding. And then lastly, you're just going to use Ohm's law, and then rinse and repeat. So you're going to use Ohm's law to work backwards to find the voltage and current into the systems. And then once you find, well, first you find Ohm's law of the overall. So your V applied, your I total, and your equivalent resistance. Then you work backwards and you find the voltage and current in each system. Then you break that system down into those parallel resistors, find the voltage and current across those, and lastly you should be able to find the voltage and current across those series resistors that were left over. So let's just dive right in and do an example. You're going to have to know the parallel and series rules as well as Kirchhoff's rules for this. So if you need help with those, please see the series circuit video or the parallel circuit video and the general electricity video. So here's our circuit. I'm going to do this nice and big, and I'll go to other slides if we need to. Oops. Alright, so I have 1, 2, 3, 4, 5, 6, 7 resistors in this circuit. I'm going to put R4 on the inside here. Alright, so I have these 7 resistors. So I need to find the voltage and the current across each of these resistors. Here are the values. I'm going to do the resistor values in blue. 1 ohm, 2 ohm, 1 ohm, 2 ohm, 3 ohm, and then 4 ohm, 5 ohm. So that is our value in ohms. So blue stands for resistance, which is ohms. I'm not putting the label because I'm trying to save space. So rule 1, combine anything in series. So these are in series, so that system is really 3 ohms. These are in series, so that system is really 9 ohms. And we do that because the series rule is you just add them together. Rule 2 says resolve parallel systems. I skipped one. Look at me. Look at this little series system hanging out here. 1 plus 2 is 3. Now I'm ready for the next step, which is to resolve this parallel system. That parallel system is 2 3 ohm resistors in parallel. Now there are some shortcuts to doing this, but I want to show the long way. So 1 over 1/3 plus 1/3. So that's 1 over 2/3. You flip that, that's 3 halves. So that's the same as 1.5. So this is extremely messy. So what I like to do is I like to then draw a circuit that shows our systems. Oh, and our battery was 12 volts. So I have a 12 volt battery. And I have the first system, which was 3 ohms. It went into this system, which was 1.5 ohms. And down to this system, which was 9 ohms. So I have my 3 systems represented here. And if it helps you, if you're a color-coded person, you can do that. So I had these as blue, and that one as purple. So now I'm ready for the next step, which is combine all of my systems that are in series. So now I can combine all these to create yet another circuit. And really that circuit is a 12-volt battery. That is 3 plus 9 plus 1.5, which is 13.5. So now I can then start to apply my 4th step, using V equals IR to find the overall. So 12 equals I times 13.5. Divide each side by 13.5. That's 0.888888, so we'll just do 0.8889. So there, I have found my first steps. My applied voltage is 12. My equivalent resistance, let's do that in blue. My equivalent resistance is 13.5 ohms, and my total current is 0.8889 amps. And so that was step 4. So now I can then work backward into these systems to find the voltage and current going into each system. So if I know at this point in time I have 0.8889 amps, stick with my color here, green, 0.8889 amps, and I know my resistance is 3, voltage is what's going to change here. I know resistance is 3, I know current is 0.8889, so I just multiply them together. 0.8889 times 3 gives me a voltage in this system of 2.6667. We keep going. 0.8889 also goes into this system. So 0.8889 times 1.5 is 1.333 or 1.334. So my voltage in this system is 1.3334. And then lastly, I have my 0.8889 again going into that resistor. So 0.8889 times 9 is 8 volts. And so if I add all of these voltages together, they darn well better equal 12. So 8 plus 1.33333 plus 2.66666 gives me 11.9999999, which is 12 volts. So we're in good shape. But now we need to back up again into the systems. So, because now that I've done it within the system, I have to break that down by resistor. So this looks pretty nasty. So I think I'm actually going to go forward and redraw it. So I have my 12 volt battery. First was this system right here. So I had 0.8889 amps of current and 2.6667 volts. So I'm going to write that so I don't forget. And how was that system made up? It was made up of a 1 ohm resistor and a 2 ohm resistor. So a 1 ohm resistor and a 2 ohm resistor. So these are in series, meaning the current, if you remember series rule, is going to be the same. So my current is going to be 0.8889 in both of those. And if you remember your rules, resistors in series means my voltage have to add up to be the total. Well, if I know that my total voltage in that system is 2.6667, these two voltages better add up to that. So 0.8889 times 1 is 0.8889. And 0.8889 times 2 is 1.7778. If I add those together, I get 2.6667. So we're good there in that system. So I know my current and I know my voltage in that. So now let's come to this next system, which, if you recall, was two resistors that were both 3 ohms. And I know this one I'm going to change, but we want to stick with this just for now. So into that system, they were both 3 ohms. And if you recall, it was 0.8889 amps and 1.3334. So let's write that up there. Well, now we're in parallel, so my rules change a little bit. What that means is this voltage, 1.334, is going to go into both of those resistors, and my current is what's going to change. So if I take 1.3334 volts divided by 3 ohms, I get 0.4447, or 0.4446666, so 0.4447 amps in each of these. 0.4445. Both of these get 0.44445. Now, that being said, I know that this one actually has another resistor that does that. So we can change this to then reflect that it's actually 1 and 2. 1 and then 2. And so I know that current has to stay the same. So guess what? 0.4455, that's going to all 3 of those. Because see, these are in series, so it has to be the same. And that confuses a lot of people because they're like, well, the 1, the 2, and the 3 don't add up to 0.4445. Well, or to 0.8889. Well, you're right, but these two resistors here, those two paths do add up to 0.8889. The only reason this one is also included is because it's in series. So you've got to really remember those rules. So now I know that the 1 ohm resistor is 0.4445, the 3 ohm resistor is 0.4445, and the 1 ohm is 0.4445. What that allows to change is the voltage. So I know that 1.3334 is what went into this resistor. So no need to change anything. However, both of those resistors have to add up to be 1.3334. So let's check it out. If I take 0.4455 or 0.4445 and I multiply it by 1, I get obviously 0.4445. And if I take 0.4445 and I multiply it by 2, I get 0.889. If I add those together, guess what I get? 1.3335, which is what we expected. So now I know my voltage across each of those resistors, and we keep going into our final system. Our final system was this one right here, 8 volts and 0.8889 amps. So let's write this down here. 8 volts, 0.8889 amps, and that was broken down into 2 resistors. Let's give it a little room here. Those resistors were 5 and 4. And so I know that the current has to be the same because these are in series. So 0.8889, 0.8889, and I know that due to Kirchhoff's second law, that these two voltages better add up to 8. Excuse me, I'm sorry. So if I take 0.8889 times 5, I get 4.4445. And if I take 0.889 times 4, I get 3.5556. Add those together, and what do you get? Of course, 8.0001. And so I've effectively used up all of my voltage. All of my currents and voltages are sound to my laws. So how I would write this is the voltage V1 is 0.8889, I1 is 0.8889, V2 is 1.7778, I2 is 0.8889, V3 is 0.4445, I3 is 0.4445, V4 is 1.3334, and I4 is 0.4445, V5 is 0.8889, I5 is 0.4445, V5 is 4.4445, and I5 is 0.8889, and V6 is 3.556, and I6 is 0.8889. So that's a complex circuit that is very similar to what I'll expect you to do in the test. Again, if you have any questions, please let me know.